already. Do you know this cross product? Yes.
Sorry, sir.
Yeah. Do you know this cross product? So to derive this torque, we have to know about this cross product, right? So
Yes, sir.
yeah, then yes. So that is okay. So cross product, did we discuss it before? The cross product? I guess we have discussed, it, right? Right, Alam.
Yes,
So
I think we discussed, but I don't remember that one.
oh, okay, okay. So okay, so just send me the question about the instantaneous velocity, right? And then I will talk about this torque, right? So what is so in this way we can remember this easily that we have this linear thing, right? Linear motion, rectilinear motion, and then we have this rotational motion. So all these have rotational analogs. So the linear motion, we have this distance, we have this velocity, we have this acceleration, right?
Yes,
And
sir.
we have this force, and we have this momentum. So, and we have this mass also, right? So, in the rotational motion, this x is changed to theta, right? Angular distance, angular velocity, angular acceleration, and the rotational analog of force. That is the torque, right? And rotational analog of momentum is angular momentum, and rotational analog of mass, what is that? Inertia, right?
Yes, sir.
Okay. So to derive the relation between torque and angular momentum, so we have to remember that A cross B, right? This
Yes,
is AB sine theta and n cap, right? Where where
yes,
what is this n cap direction? So let's say that okay. So let me okay. So you have two vectors, right? This is A and this is B. And you are taking the cross product of A and B, and you are finding out that what would be the direction of A cross B. So you place your palm, right? You place your
yes,
palm in your A vector direction. Your thumb points out in the direction of A, and then you curl your finger in the direction of B. So whatever direction your thumbs point out, so that would be the direction of the A cross, normal to this surface, right? So
yes, sir.
so that is why I discussed this at some point that you have these three vectors, right? So you have these three vectors, right? So this is your x, this is your this black one is your y, and this is your z. This one is your z, right? So whenever you take cross product of I cross j, so you get this one, y, right? So that is
Yes,
how I discuss these cross products, right? So you have three perpendicular vectors, right? Let me, yeah. So I have these three perpendicular vectors, right? So you have this x, you have this one, which is y, right? In the plane. So in the plane, I have this x and I have this y. And
yes,
then this height is showing me the z direction, right?
yes, sir.
So when I take cross product of I cross j, so I get this k. So this we have discussed, right?
Yes, sir.
Okay, so that is how we get this direction of A cross B using the right hand thumb, right?
Yes, sir.
And what is the use of this cross product? So we already know that what is the use of this dot product? Dot product is used in our work and power and other things, right? So this is where the dot product is used. So work is F dot S, right? This we have discussed.
Yes, sir.
Similarly, your torque is, this is R cross F, right? So this is called moment of force. When I will discuss about these, I will talk in detail. I will just, and angular momentum is R cross P. So this is momentum, momentum, right? And we already know about the fourth chapter. So in the fourth chapter, you already know that how this force is related to momentum. How this is related? How force and momentum are related?
Mm, uh,
Second law of motion.
it's
Second law. What is second law of motion and how? What does this second law gives? Hmm. Think about it. Newton's second law of motion. First law is inertia, right? You know that. Second
yes,
law talks about what?
sir. Force.
Yes.
So isn't force equal to like the change of momentum in
Yeah.
changing
Yeah.
delta P by delta T?
Yeah. So that is average force. But instantaneous force would be dp by dt, right? This is our second law of motion, right?
Yes, sir.
Good. So I will also revise this fourth chapter quickly, right? But keeping that in mind, so I have this momentum, right? And I have to get force out of it. So what I will do is that, and one thing more that, right? So this is there. And second thing about the cross product, that if I take a cross product with itself, right? So what would be that? Can you tell me? What would be that? Okay, let me give you a hint. This would be a sine theta, right? Now think from this point.
It will be zero.
Zero. Why? Absolutely right. Why?
So because the angle between A and A will be zero, so sine zero will be
Absolutely right. So whenever we multiply, we take the cross product with the same vector, that will give you C. Good. So then, now let us get back to the definitions of angular momentum, right? This is R cross P.
yes, sir.
And differentiating it, so differentiating it with respect to t. So this would be dl by dt, right? And this would be d by dt of r cross p, right? Right, Ilham?
Yes,
Yes.
sir.
So again, using the product rule, right? These are products. So first, I will keep r outside, and
Yes,
then dp by dt. And what then what I will do, remember this is a cross product, so we should not change the places. So then
okay.
I will take the differentiation of R and keep the momentum as it is. Understood?
Yes, sir.
Okay. So now can you tell me what is momentum? How momentum is defined?
So
What is the definition of momentum?
I don't know the definition.
Product
Uh,
product of what? Product of, it is product of two things, right?
so mass and velocity.
Right. So you knew then why. So this is happens when you are panicking and you are not thinking it right.
Yes,
So be patient, right? Don't think too much. You know everything, right? You have studied, so you know everything. Just calmly think about. Okay, so this we know, right? So keeping this one intact. R cross dp by dt is what? dp by dt. Rate of change of momentum. This you already
force.
told
So
me.
force.
Right, yes.
Force.
So force. Good. And plus this dr by dt is what? Rate of change of, this is position vector, right? Rate of
Yes,
change of position, what is that?
velocity.
Velocity, and you know that this momentum is mass into velocity, right?
Yes,
So,
sir.
so then your angular momentum would be, this is r cross f. R cross f we know that is torque, right?
Yes, sir.
Plus m is a constant, so we can take it outside, and this would be v cross v. What would be v cross v?
So zero.
So this cancels, and we got torque, which is related to angular momentum as. So this was. Did you ask this derivation? Yes.
Yes, sir. Yes, sir. This derivation.
Good. So
Sir, can I copy it? Yeah.
absolutely, absolutely. Why not? So okay. So we should start from where? This part is important, right? So
Yes, sir.
so Amna may be preparing, and that's why she is not coming, right? So
Yes, sir.
it's a system of particle, and in system of particle, that laminar question, that is very important. So you please prepare that question, because in system of particle the most important thing that they will ask you is they will ask you to calculate the moment of inertia of some different combination. And yeah, so please prepare that. And in work energy and power you have this work energy theorem, and then this collision. So yeah, please prepare
So
that.
collision is a little bit difficult. Sir.
Collision is difficult. Why collision? Collision whenever, so okay, so I will talk about that also.
So can you scroll down? So can you scroll?
Yes, yes. Okay,
Done,
whenever
sir.
you done, good. So, okay, in collision, what are the things that you have to remember, right? So, we have, and this collision in one day is more important, right? So, collision in one day, right?
Yes.
So
Yes, sir.
we have to remember that there are two kinds of collision, right? One is this elastic collision, and the other one is this inelastic collision, right? Collision. So what happens in elastic collision that momentum is conserved and kinetic energy is also conserved, right? And
Yes, sir.
in there is no loss of energy, right? And in this also momentum is conserved, but kinetic energy is not conserved. And there is a loss in the form of heat and heat. Right? So there is some loss of energy in the form of heat. Right? There is some loss of energy. Okay, so in energy, so the most important thing about this elastic collision is that its coefficients of restitution, right? Or what is it? Constant of restitution that is denoted by E. This is 1. And in this one, this constant of restitution is between 0 and 1. So this is about this inelastic, right? So in elastic collision,
Yes.
you have learned that you have these two objects, right? And what you do is that let's say its mass is m1, this is m2, this is moving with velocity u1 vector, this is moving with u2 vector, and then they collide, right? They collide head on,
Yes,
right?
sir.
And then what happens is that so this is the initial stage, then they collide, and then they move with a different velocity. So now it is moving with v1 velocity, and this is moving with v2 velocity, right? So now what you do is that what are the things that you already know? What are the things? So this is the example of elastic potential. Okay. So what are the things that you know? You know U1, you know U2, and you know M1 and you know M2, right? So
Yes, sir.
then you have to find out that in collision, you find out that what would be these velocity. So you have to find out V1, you have to find out. This is the thing that you calculate, right? So
Yes, sir.
what you do is that you apply first you apply the conservation of momentum, conservation of momentum, right? So this says that M1 U1 plus M2 U2. This would be how much? This would be M1 V1 plus M2 V2, right?
Yes, sir.
This is the first case. So who is texting?
Yes, sir.
One moment. One. Okay. So conservation of momentum. You apply this thing. And what is the other information in elastic collision that you know? What is the other information? So this we use that P initial would be equal to P final, right? And P
Yes,
initial is what? This is the momentum of one particle, right? This is the momentum of second particle. This is the final momentum of one particle. This is final momentum of second particle or object. So then you use this conservation of momentum and you got this equation, right? Now, what is the other thing that you know in this one? What is the other thing that you know?
sir.
Sorry.
Kinetic energy is conserved.
Absolutely right. So what would be the kinetic energy of the, what is the kinetic energy of, so what is the kinetic energy conservation? So you tell me that what is the kinetic energy of this guy? What is the kinetic energy of this guy?
So half M1 U1 square
Absolutely right.
plus half uh, M2 U2 square
Yes,
equals to half M1 V1 square plus half M2 V2 square.
yes, very good. So half M1 U1 square plus half M2 U2 square. This is equal to half M1 V1 square plus half M1 M2 V2 square. So half is cancelled, right? Then you have to find out that. Then you have to find out that what would be the value. Remember, what are the things that you have to find out? What is the goal? Goal is to find out V1 and V2. This is the goal, right?
Yes, sir.
And this in the form of what? In the form of M1, in the form of M2, U1, U2. This is the idea. Okay. So we have to solve these two equations, right? So let us solve these two, right? So what we can do is that we can find out value of one thing, right? So, but let us use this one. So from here, right? m1 u1 square plus m2 u2 square. This would be how much? This would be m1 v1 square plus m2 v2 square, right? So
Yes, sir.
let us let us take, so this is m1 u1 square and minus m1 v1 square, and then this would be m2 v2 square minus m2 u2 square, right?
Yes,
So,
sir.
so this, if I take m1 common, so this would be how much? This would be u1 square minus v1 square. And then if I take m2 common from here, so this would be v2 square minus u2 square, right? So then what you will have? So you will have m1, and this would be u1 minus v1 and u1 plus v1, right?
Yes, sir.
And then what you will have in here? So you will have v2 plus u2 and v2 minus u2, right?
Yes, sir.
So then what you can do from this equation? So you have this equation. So what you can do is that you can write this equation as m1 u1 minus of m1 v1. This is equal to m2 v2 minus of m2. So you can calculate that m1 and u1 minus v1. This is m2 and v2 minus u, right? Correct.
Yes, sir.
So what you can do from here? So you know that what is m1 u1 minus v1. You know that, right? Right?
Yes, sir.
So you know what is m1 u1 minus v1, right? So this is m2 and v2 minus u, right? Putting the value of m1 u1 minus v1, right? And let us write this as so this is equation first, this is equation second, this is equation third, right? And putting the value from equation third.
Yes,
So
sir.
from equation third. So this is m2 and then u1 plus v1 equal to m2 v2 plus u2 and v2 minus u. So what is cancelling? Allow. What is
Sorry, sir.
cancelling then?
So V2 plus U2 and you can cancel
V2
that.
v2 plus u2. So you there you see that m2 and m2. This cancels out.
Oh, oh, yeah, okay, sir.
And you find the other one. So not okay, you find the other one. Okay.
Okay, sir.
Yeah. So you have four terms, right? Which one is
Yes.
cancelling? Yes.
Sorry, sir. We,
Which one is cancelling alarm? Which one is cancelling? Hmm. So let me write. So this is first term. This is second term. This is third term. This is fourth term. Which one is cancelling?
so can we cancel first and third one?
Right. First and third. No. First and what? So this is u
Oh,
v v2 minus
sir, First and fourth one.
right? These are equal, so they will cancel
Yes,
out,
sir.
right? So, okay. So these are canceling out, and don't panic. Why are you panicking? Don't take too much pressure, right? So U1 plus V1, this is V2 plus U2, right? So what was the goal of this calculation? The goal of this calculation was that we had to find either V1 or V2. So now we can find out what is V2 from here. Okay, so V2 would be how much? V2 would be U1 minus U2 plus V1. Okay,
Yes, sir.
so this we know. Now what we can do is that let's say that this is the equation 4. So now we can put the value of V2, right? Because what is the goal? Goal is to find out V1 and V2 as functions of M1, M2, U1, U2, only these. Okay,
Yes, sir.
so now we have this V2. So where can I put this V2? Just go back here. So the first equation, right?
Yes, sir.
I can put this value in the first equation. So let us put the value in first equation. So put the value of uh, V2 in first equation. Okay, so what we'll get? First equation was M1 U1 plus M2 U2. This is M1 V1 plus M2 V2, right? So let us put the value M1 U1 plus M2 U2. This is M1 V1 plus M2 and V2 is how much? U1 minus U2
U2 plus
plus
V1.
V1. So then we solve these equations. M1 U1 plus M2 U2 equal to M1 V1 plus M2 U1 minus M2 U2 plus M2 V1. Right.
Yes,
So
sir.
then what would be this equation? So this is M1 U1 plus M2 U2 and plus M2 U2 minus M2 U1 and then this is equal to M1 V1 plus M2 V1, right? So if I solve this one, what would be this? M1 U1 minus M2. So this would be M1 minus M2, right? U1
U1.
and then is this would be plus M2, right? M2 U2 M2 U2.
Yes, sir.
So this is 2 M2, right?
Yes, sir.
So did I write it correctly? Okay, so U1 V1 is V2 is minus U2, right? So U1 minus U2 plus V2. Okay. So then U2 goes in the other side. So this is correct. So then we have this M1 plus M2 common, and I have this V1, right?
Yes, sir.
So V1 would be how much? This would be M1 minus, or let me write it as 2M2U2 divided by M1 plus M2, right? And plus m1 minus m2 u1 divided by m1 plus m. So this would be v1, right? Is this
Yes, sir.
much long? Okay. Is this much long? Okay, and then when I put the value of this v1 in this equation, right? So I know that my v2 is how much? My V2 is U1 minus U2 plus V1, right? U1 minus U2 plus V1. So then this would be how much? U1 minus U2 and plus of V1 is M1, or let me write it as 2M2 U2 divided by M1 plus M2, right? And plus M1 minus M2 U1, right? So if I solve this one, this would be how much? This would be M1 U1 and minus M2 U2 and plus how much? Then, okay, let me write it. So M1 U1 and minus M1 U2 plus M1 M2 U1 minus M2 U2, right? Plus 2M2 U2 plus M1 U1 minus M2 U1 divided by M1 plus M2. So this was just a lengthy calculation, right? This was just a lengthy calculation allowed. So that
Yes,
is
sir.
why, yeah, that is why I don't think about. So
So why did we add 2m to u2 plus
yeah,
m1?
so you see that this is what? So this is what we got. 2m2
Yes, sir.
u2 plus divided by m1 plus m. So that is what I 2m2 u2 plus m1 minus m2, right?
Oh, so it's value of v1, that's why.
Yeah, yeah, value of v1, value of v1,
Oh,
right?
okay, sir.
Okay, so then what is cancelling? Why there is nothing which is cancelling? So m2 u2 and m2 u2, right? And then m1 u1
Do we have
m1
to
u2.
write this much in exam or collide?
Yeah, so M2 U1 is, yeah, this much we have to write. Yes. And then this is 2 M1 U1 minus or plus. So we have this M1 U1 and so then minus M1 U2. There is some problem, right? There is some problem with this, guys. That is why this is okay. So did I do it mistake? So what is V1? Let me check what is the V1 that we normally get. So we generally get one as, what is one that we get? M1 upon M1 plus M2 V1. So we generally get, yeah. So M1 V1 by M1 plus M2 and V1 is, so V1 is so this is what we generally get. V1 is m1 minus m2 and u1, right, divided by m1 plus m. This is what we get, and then v2 is 2m1 v1 and m1 plus m2. Okay, but they assume that, what do they assume? Oh, so this is what they assume. Good. So what is the different thing that I have done? Right. So this is the case.
Yes, sir.
In your class, you have a simplified case. And to tell you that what is the simplified case? So the simplified case is that, so okay, this much calculation I did. So the simplified case is that you don't have this u2 velocity, right? So this thing is at rest. Okay. So this u2 is at rest. So if this u2 is at rest, then what we will get in here? If u2 is rest, then what we will get? V1 would be what?
Sorry, sir.
u2 is 0, then what would be V1?
So then it would be uh 2m2 by m1 plus m2.
This is 0, this
Yes.
is 0. Whole thing would be 0, right? This is 0.
Oh, u2 is 0.
So this whole thing is 0, right?
Yes, sir.
So V1 would be M1 minus M2 U1 by M1 plus M2, right?
Yes, sir.
Which is what we get here. So I have just complicated things, right? We have to take this simplified things. So you have to take that U2 is 0. So whenever you reach in here, right? Whenever you reach here, you assume that your U2 is 0. Okay. So if your U2 is 0, then what will be in here? So U2 is 0. Then what would be V2? V2 would be this part is 0, this part is 0, this part is 0. So 2 M1 U1 by M1 plus M. This is what you get. Right? 2 M1 U1 by. So this is what you are getting
Yes,
on.
sir.
So what you can do is that you solve up to this point and take U2. Then you will get what is written in the book. Right? So this was the idea of elastic collision. Understood?
Yes, sir.
So this is just a lengthy calculation that we have to do. So nothing more than that. So do you want to note down this part?
Yes, sir. Just
And what you do is that you just take u to 0 from the start. You know the idea, right?
yes, sir.
So the thing that you have to study is that this object is moving and this is at rest. So this is at rest. And then you have these two velocities. So then you have to solve these two.
So can you scroll?
Yeah. Yeah. Should I scroll it down?
Yes, sir.
Okay. And just remember that in your case, right, in your syllabus, this Q2 is 0. So then in that way, you have to calculate. Okay.
Okay, sir.
So from the start, you can take U to 0 and then solve for the rest. Should I do
Okay,
that or should I do that? So let us do that, right? Forget about these and
sir.
ultimately we will get the same result, but this is more lengthier. So we have to write the simpler version, right? So when U2 is 0, right? So then you have two equations. Let me quickly write. M1 U1, this is equal to M1 V1 plus M2 V2 from the momentum conservation, right?
Yes,
And
sir.
from kinetic energy conservation, half M1 U1 square, this is half M1 V1 square plus half M2 V2 square, right? So half, half, half cancel. And I have M1 U1 square. This is equal to M1 V1 square plus M2 V2 square, right? So now what I can do is that I can find out what would be, so this is M1 U1 square, right? Minus
Yes,
M1 V1 square, this is M2 V2 square. Following the same process that we did. So this would be how much? This would be M1 and U1. So M1 is taken, U1 square, V1 square. This is M2 V2 square. We will follow the same steps. So M1 is U1 plus V1, U1 minus V1. So what we will do next? Alarm, do you remember? We will calculate the value of M1 minus V1 from here. So M1 U1 minus M1 V1 is M2 V2. So M1 is U1 minus V1 and M2 V2. So M1 U1 minus V1 is how much? M1 U1 minus V1, how much now?
sorry, sir.
M1 U1 minus V1. This is how much? M2 V2.
M2 V2.
So M2 V2 and then U1 plus V1. Right. So which is cancelling? This part cancels this. Right.
Yes, sir.
So we have V2 equal to U1 plus V1. So this is what we got. Right. And then we can put the value of V2 in here. So we can put the value of V2 in here, and then what we will get, M1 U1 equal to M1 V1 plus M2. And what is V2? U1 plus V1. So U1 plus V1. So M1 U1, M1 V1, M2 U1 plus M2 V1. So this M1 is common, right? Or V1 is common, right? So let me write it properly. All the V1 in one side, all the U1 in other side. This would be M1 U1 minus M2 U1. Correct? This would be M1
Yes,
V1
sir.
plus M2 V1. So this is M1 minus M2, and this is M1 plus M2. So we will get V1 as U1 M1 minus M2 divided by M1 plus M2. So this is what we will get. This is what we had to do, right?
Okay, sir. Yes, sir. Yes.
Similarly, how can we get V2? How can we get V2 U1 plus U1 M1 minus U1 M2
Sir, your
divided by
voice is
M1
lagging.
plus M2. My voice is lagging. Am I audible now? Am I audible now? Yes.
Yes, sir. Now it's audible.
So M1 U1 plus M2 U1 plus U1 M1 minus U1 M2 divided by M1 plus M2. So which is cancelling M2 U1 M2. So you have 2M1 U1 divided by M1 plus M2. So this is what you get in elastic collision. Okay.
Yes, sir.
So you please note down this simpler one. This is simpler one,
Okay,
right?
sir.
This was,
Yes.
this was a complicated one because I took this U2 to be non-zero, right? So you note down that is not needed. So you please note down here.
So how will they ask this in the exam? Like they'll tell to derive the
Yeah,
velocities.
yeah. So first they will ask you to derive this relation, that what would be the final velocity in elastic collision, right? So they will say that, they will ask that, let's say two objects of mass, let's say two objects, or two objects of mass, let's say 3 kg and 4 kg are there, right? And 4 kg is at rest, but 3 kg is moving with, let's say, 20 meter per second, right? And strikes
Yes. Yes, sir.
strikes the 4 kg one. So we have to find the final velocity of object 3 kg and object 4 kg. So this can be the question, right? So you have to find V1, V2. So you know that V1 is M1 minus M2 divided by M1 plus M2 U1. And you know that V2 is 2 M1 U1 divided by M1 plus M2. So you can apply this. You know M1, you know M2, right? You know M1, you know M2, so you know also U1. So in this way you can calculate, right?
Yes, sir.
Yeah. So okay. So please note it down. So whenever you want me to scroll down the screen, please tell.
Yes, sir. Yes. So can you scroll?
Yeah. So there is one another collision, right? So that I will talk about in the right. So in the later class, right? Today, and I will also revise some portion of fourth chapter. So did you revise that banked road and unbanked road?
No, sir. I didn't do that yet. I'm planning to do it now.
Oh, okay. Yeah. So I will also revise the fourth chapter, right?
Sir, can you scroll?
So
Done, sir.
okay, so then I'll see you on what? So at 7:30. No, not 7:30. At 6:30, right? Okay.
Yes, sir. 6:30.
Okay. So prepare well and don't panic. Okay, Salam.
Yes, sir. Sir, the only
Yeah.
panic is
So
there because there's so many things to remember.
yeah, your voice is breaking. Yeah, your voice is breaking. Now, what are you saying? Hello, hello.
Sir, can you hear me now?
Yes. Yeah.
Sir, I was saying that there are so many things to remember. That's why.
Yeah, because you started when? So only 3 days before. That is why I kept so okay. Don't worry about those things now. Now you have started, just prepare and yeah. So okay, Allah Hafiz, Alam, and see you at 6:30.
Sir, can you just
Yes.
take 2 minutes and solve this question? Just one I
Which
have
question?
now.
Yeah, which question?
Sir,
Which question?
I sent in the chat box.
Okay, so the displacement of a particle is given by calculate. This question we did so many times. So 18t plus 5t square, right?
Sir, I was just
Displace.
confused. I don't know what
No,
to
no,
say.
no. So no worries, no worries. So 5t square, right?
Yes, yes, sir.
So we know that what is the instantaneous velocity? That is dx by dt, right?
Yes, sir.
And what is average? That is delta x by delta t, right? Which is x final minus x initial by t final minus t, right?
Yes, sir.
So what is from average velocity we have to find from 2 to 3 and instantaneous at 2 seconds. So we have to differentiate this one. V is dx by dt, right? So
Yes, sir.
d by dt of, let me write as 5t square plus 18t. So what would be that? You have done this calculation yesterday. D by dt of 5t square plus d by dt of 18t, right? So what would be that? Yes, 5 is taken outside, d by dt of t square. And then 18 is taken outside dt by dt, right?
Yes, sir.
Right, Alam?
Yes, sir. Yes.
So differentiation of t square, what would be that? 2 into t 2 minus 1 plus this is 1, right? dt by dt is 1. So this is 10t plus 18, right? This is
Yes, sir.
v as a function of t. And we have to find out the velocity at 2 seconds. So 10 into 2 plus 18. So this is 20, so 38 meter per second, right?
Yeah, okay, sir. Yes.
Understood, Ilham?
Yes, sir. Thank you, sir. Sir.
next को क्या?
So can you hear me?
Yes. Yeah. Now I can hear. Yeah. So understood this part?
Yes, sir, I understood.
Yes. Can you hear me, Elham?
Yes, I can hear you.
There's some
That's
problem
it.
with this.
That was my doubt. I know the second part of the question.
Yeah, you know